Alright, now in part D we've got just rewriting that equation so you can see it on screen. X cubed plus x squared plus 2 equals 0. And you have the original roots again, being alpha, beta, gamma, same as before. But you're trying to find alpha to the 4 plus beta to the 4 plus gamma to the 4. Now again, we can use that original method. So we can make it x to the quarter cubed plus x to the quarter squared plus 2 equals 0. Finding that new equation will give alpha cubed, alpha to the 4, beta to the 4 plus gamma to the 4 as the 3 roots. And you get x to the 3/4 plus x to the half plus 2 equals 0. And you can do that to the power of 4 and get a cubic, right? So you could make that x to the 3/4 and put on the other side negative, actually it'd be easier to make that negative over that side and make this x to the half plus 2. Now, you could to the power of 4 both sides, right? On this side you'll get x cubed. Here, it's not going to be clean. You're not going to get something cleaning itself up quickly. So it's not the ideal way to do this. You actually have to do x to the half plus 2 to the power of 4. It's just that you will get left with messy stuff in that equation, which will not help you answer the question. And so that's not the way to do it. Instead, it's more beneficial to realise you're actually halfway there. So in part B, you actually found a question where the roots were alpha squared plus beta squared and gamma squared. So that was alpha squared, beta squared and gamma squared were the roots of the one we found in B, which is x cubed minus x squared minus 4x minus 4 equals 0. So the reason that's beneficial is because we can go, well, alpha to the 4, beta to the 4, gamma to the 4 are the square of those roots. And because those roots, alpha squared, beta squared, gamma squared, can be squared, we can generate a new equation using that same format, x to the half cubed minus x to the half squared minus 4x to the half minus 4 equals 0. Okay, that leaves us with x to the 3 on 2 minus x minus 4x to the half minus 4 equals 0. Now, if we pair these correctly, we can get a good solution. So it's actually about moving things the right way. In moving things the right way, we can actually get the two halves on the one side and the two non-halves on the other side. So we get x to the 3 on 2 minus 4x to the half. They're the ones we want together. And then on the other side, x plus 4, they're the ones we want together. So we're going to square both sides. The reason we're going to square both sides is because we want to get an equation that will actually work for us. And I believe that squaring will give us that equation. Plus we need 3 roots, and squaring is going to give us a cubic, so that a cubic should have 3 roots. So the square of this is x to the power of 3 minus 2 plus 2 lots of, so that's minus 8 x, and when you add the two indices, it's 1, because it's 2, because it's 1.5 plus a half, which is 2. So that's double the product, and then the square of this last term is plus 16, and then x to the half squared is just x to the 1, which is x. On the right hand side we've got x squared plus 8x plus 16, nice and easy. Combining all that together, we get x cubed minus 9x squared plus 8x minus 16 equals 0. And because we want alpha to the 4 plus beta to the 4 plus gamma to the 4, that is the sum of the roots one at a time, which is equal to minus b on a, which is equal to 9. And that also happens to be the answer. So a sneaky trick there in order to get that one working better.